Welcome to Spring LIB.
In this question, given data is that is first there is a figure given. So first I will draw this figure and explain the data given. So the figure is that is there is a horizontal ground is given, and then after it on this ground there are two blocks of mass having mass, that is first block is mass having that is m1, and second block having mass that is m2. Now in the question it is saying that they both blocks are connected by a spring having spring constant that is given, that is equal to k. Now further in the question given data is that is the block of mass m2 is given a impulse so that it required a velocity towards right, and velocity is that is v naught. So here this data is given, and now there are two parts is given, so we have to find out in the first part, that is a, that is it is saying that find the velocity of center of mass, and in the second part, that is part b, it is saying that we have to find the maximum elongation that spring will suffer. So now let's start answering this question. So I can say that here first I will try to answer the part A, then after it I will try to answer part B. So in the part A it is saying that we have to find the velocity of center of mass. So I can say that for part A the given data is that is velocity of mass m2 is, that is for second block is that is v naught, and velocity of mass m1 has, that is first block, that will be equal to 0 because it is in rest position. So now next step is the velocity of center of mass will be written as, by using the formula I can say that velocity of center of mass will be, that is vcm is equal to m1 v1 plus m2 v2 divided by m1 plus m2. Here vcm is a velocity of center of mass. So now next step is substitute the data, that is here substitute v1 that is equal to 0 and v2 that is equal to v naught. So it will be written as, that is result will be vcm is equal to m1 multiplied by 0 plus m2 multiplied by v naught divided by m1 plus m2, or I can say that after solving I will get vcm is equal to, that is m2 v naught multiplied by divided by m1 plus m2. So this is the answer for part A, that is velocity of center of mass will be written as, that is m2 v naught divided by m1 plus m2. Now next step is, here I am trying to answer for part B. So in the part B it is asking that we have to find maximum elongation in the spring. So now let's consider that the maximum elongation in the spring is, that is x. So my next step is, I can say that the spring attains maximum elongation when the velocity of both block become equal to velocity of center of mass. That means for maximum elongation it is required that mass of velocity of first block, that is v1, and velocity of second block, that is v2, will both are equal to center of mass, that means is equal to VCM. So now next step is, after knowing this information, my next step is here applying the law of conservation of energy. So according to this law of conservation of energy, the result will be written as, that is, change in kinetic energy is equal to potential energy stored in the spring. That means here left side I will write the change in kinetic energy. So I can say that half m2 v0 square minus half parenthesis of m1 plus m2 multiplied by vcm square is equal to, now on the right side write change in the potential energy stored in the spring, that it will be equal to half kx square. Now next step is put the value of VCM, that is velocity of center of mass, from part A, which I had answered for this VCM, that is equal to m2 v0 divided by m1 plus m2. So here after replacing this, I can say that the next step will be half m2 v0 square minus half m1 plus m2 parenthesis of m1 plus m2, and VCM square will be written as, that is m2 v0 divided by m1 plus m2 whole square is equal to half kx square. So now next step is simplify it, then it will be written as, that is half m2 v0 square minus half, here after simplifying this second term on the left side it will be written as, that is half m2 v0 square divided by m1 plus m2 is equal to half kx square. Now next step is take a common, that is m2 v0 square on the left side, so it will be written as, that is, and also take a half common, so it will be written as, that is half m2 v0 square, and inside will be in the parenthesis I can say that 1 minus m2 divided by m1 plus m2, that will be equal to half kx square. So now simplify it, then I will get the maximum elongation in the spring, that is after simplifying value is, that is v0 multiplied by, in the bracket, square root of, answer will be, that is x is equal to v0 square root of m1 m2 divided by parenthesis of m1 plus m2 multiplied by k. So this is the answer of given question. That means I can say that for part B the maximum elongation in the spring will be, that is x will be equal to v0 square root of m1 m2 divided by parenthesis of m1 plus m2 multiplied by k. So I had answered the part A and part B. So you can see that in the part A answer is, that is VCM is equal to m2 v0 divided by m1 plus m2, and in the part B answer is, that is x is equal to v0 square root of m1 m2 divided by m1 plus parenthesis of m1 plus m2 multiplied by k. So I had solved the question completely. Thank you.